Hello, everyone. My name is Ben. I'm a postdoc at Brown, and all things considered, I'm a very happy Racket programmer. I've got to admit, though, there are sometimes days and sometimes weeks when programming feels like a big struggle against different error messages. So with these ups and downs in mind, I've really enjoyed the summer events that we've had for the past 2 years. They're a nice chance to unwind, pick up a small project, and come away with something rewarding. In 2019, we had the standard picture competition. In 2020, there was the Quick Script event looking for different ways to engineer Dr. Racket. And so for 2021, I was glad to co-organize with Stephen a syntax parse bee that I want to tell you about today. The rules for the bee were simple. We were looking for any sort of macro as long as it used syntax parse one way or another. And now, without further ado, let me tell you about some of the wonderful entries that we received. First, have you ever wanted extensible recursive functions? For example, maybe you'd like to have interpreter 0, which can evaluate numbers and arithmetic expressions, nothing else. Then later on, make a second function, interpreter 1, which adds a case for multiplication and then falls back to interpreter 0 for the rest. This kind of thing is possible in plain Racket. I mean, with enough lambdas, anything is possible. You can make your own fixed point combinator, carefully define the functions, and then carefully apply the functions to tie everything together. And this works out. But with the macro here, define extend, things are much simpler. First, interpreter 0 is the match code that we always dreamed of. There's one case for addition, one case for numbers, and nothing else. Then interpreter 1 extends interpreter 0, adds a case for multiplication, and then falls back to 0 for the rest. Very nice. The next entry here deals with some new notation. So as you know, if you have an object h and you'd like to call a method, you need to type in a few keystrokes. Open paren send, h, method name, arguments, close paren. And similarly for vectors, when you want to read from a vector or write to it, you need to call vector ref and vector set as appropriate. With a macro, this can be cleaned up considerably. So our method call is now h.run. And for the vectors, we have this underscore notation to do a reference and the colon equals to do a write. On a similar note, another entry dealt with a syntax for hash tables inspired by JavaScript. So on the left, we define a table with 3 items inside. Then we give names to 2 of the items and define a second table with everything else, missing those first 2 items. This all works, but it's much cleaner here on the right with the help of a JS extract macro. JS extract takes a schema for what names to define and how, and then it does in one line what it took us 5 lines to do on the other side. And I should point out that this JS entry also has a second macro involved to deal with dictionary creation. So there's 2 sides of the story, cleaner ways to make a dict and cleaner ways to pull things out of it. Now another one that I just couldn't resist, pirate 4. On the left, we have a normal call to andmap. First, we give it a function function expects 2 arguments, and I've left out the function body. And then we have 2 lists. Because the function takes 2 arguments, we need to give it 2 lists, and then andmap will go through and apply the function pointwise. Well, with the pirate 4 macro, you can write this whole thing in a much more convenient way. Pirate 4 uses andmap as a kind of combiner. Then it takes a spec for what names to give the different elements of the lists. And then down where the dots are, that's where you'd write the function body. So it's a very interesting way to think about higher order function application. You could try it out with other functions besides andmap and see how it works. Now, so far we've talked about several macros, but I haven't shown you any. We're going to fix that in a minute. But first, I need to make a confession. Now, I've known for a few years now that syntax templates in Racket support these 2 forms, tilde question mark and tilde @ sign. But for the longest time, I was lazy about learning what they do and how to use them. So I was really hoping with the syntax parse bee that I'd get an example or 2 to show me how they work. And of course, I wasn't disappointed. First, here's an example that uses tilde question mark. On the left, we have normal Racket syntax for defining a few values, right? A few definitions. First, you define x, then define y, one name at a time. And the second one uses define values to define 2 things at once, quotient and remainder. On the right, we have a nice macro to clean this up, define star. takes in a sequence of identifiers and values, or parenthesized a few identifiers, and then an expression. Okay, so the define star on the right is a nicer way of writing defines on the left. Here's the macro definition for define star. On top, there's the pattern. What kind of input does define star expect? And the pattern says, well, I'm looking for either an identifier and an expression, or I'm looking for a sequence of identifiers and an expression. Down below, we have the template. And the template says, we're going to do a sequence of things, and then depending on what our input was, we'll output one of two things using this tilde question mark. If we're in the first case of the pattern, and both ID and expression are defined, then we'll do a simple define. And if one of those attributes isn't bound, we'll do the define values instead. We must be in the other case. So give me a define values with a few IDVs and the expression. So tilde question at the bottom mirrors the or at the top, and this whole thing is very nicely done. Second, we have an example with tilde @ sign. On the left is a normal call to string trim. We give it a string, and then because we want to trim both sides, we give it the left and right keywords, and we have to say true. We do want to trim on the left, and we do want to trim on the right. On the other side, we have a simpler way of writing string trim, and this is enabled by a macro that overrides function application. So the trim on the right, you supply the keywords left and right, and those keywords by default take on the value true. Here's the main part of the macro that gets the job done. The macro's pattern expects a function, a sequence of non-keyword arguments, and then a sequence of keywords. And behind the scenes, those keywords may or may not be followed by a value. Down below in the template, we expand to a normal Racket app, function f, all of our mandatory arguments, and then we use this tilde @ sign to splice things in. If we have a keyword, it splices in the keyword key and the keyword value one after another. And otherwise, it expands into nothing. So tilde @ either gives you a sequence of things or gives you an empty sequence, which is just what we wanted to make a nice function call at the end. So I hope that gives you a taste and gets you excited to look at all the other entries, because like I said before, we got lots and lots of excellent ones. Here's a bird's eye view of all the different macros that we received. You can find these in their original form over on the syntax Parse Bee repo here. Everyone submitted an issue with their contribution. And you can also find them in a rendered form up on the Racket docs. There's a package, syntax parse example, which has all these examples up on one page for easy reference. So I would definitely encourage you to take a look, browse the examples, and it's a great way to learn how to do macros. There's something for everybody now inside the collection. Oh yes, and naturally, the syntax parse example repo is open to submissions. So any time of the year, you can sit down and have fun making a macro and then send it in and join the gallery. The one thing that you'll miss out on, unfortunately, is the wonderful prizes that we had this year. We had printed commemorative macro pillow stickers to celebrate the syntax Parse Bee. So for those of you who haven't heard of the macro pillow story, the legend is that in the Northeastern Programming Lab, there's a desk with a pillow on it. And if you're a tired programmer who's been dealing with macro problems, you can rest your head on the pillow and someone will talk to you. And if you don't have a solution, you at least get a little bit of consolation with your macro woes. Macro pillow has been an important part of the lab for years. Here's a picture of me at my last day at Northeastern, cuddling with the macro pillow. And this is macro pillow B2, I like to call it. Macro pillow B1 was unfortunately thrown away a few years earlier on one of those rare occasions where someone decided to clean the lab. But I mean, it just goes to show that we're PhD students working on programming and not monks maintaining sacred artifacts. I don't have any pictures for older macro pillows. So instead, here's a few pictures of people from when the macro pillow story originated. So give you a sense of what was life like in the Northeastern lab back in those legendary days when macro pillow got its start. Here's a slide with all the important links in one place. And I want to close with a big thank you. First to Stephen for being the co-organizer for this bee, and also for organizing the past competitions. And a big thank you to all the participants who contributed. all the macros that we got to see. Thank you very much.